Pythagorean theorem tells us how the side lengths in a right-angle triangle relate to each other. A right-angle triangle is any triangle where one of the angles is a quarter of a circle. The theorem can be represented in terms of areas beside the sides of the triangle. What we have here is the area A and area B sum up to give you area H. That is the theorem. It is called Pythagorean theorem because Pythagoras was the first person known to have written down a proof. His proof involved removing H from the diagram we have and substituting it with areas A and B. This shows that it takes up the same amount of space when we remove H and substitute in A and B. Let's try it with a different sized triangle. A and B are no longer the same size. Let's take them out and substitute H back in, and it takes up the same area. There are many proofs for this theorem, but we'll look at one other. It's called the similar triangles proof. In this proof, we've got a single right-angle triangle that we subdivide into two smaller right-angle triangles. We'll focus on the two angles that are not right angles, the one at the top and the one at the bottom. The angle at the bottom can be represented as the ratio of length h over the length a. That is the side opposite the right angle divided by the side next to the right angle. Now let's just focus on the small triangle at the bottom. And the side opposite the right angle is A, and we can divide that by the side next to the right angle, which is H1. Both of these ratios represent the same angle, and therefore are the same. We can change the size of the triangle, shrink down A quite a bit. H and H1 change quite a bit. So the ratios change, but they change at the same rate, which means that the ratios are still equal, even though the angles have changed. So we can do some rearranging and we get A squared equals H times H1. Let's do the same thing for the angle at the top. First, we do with the side opposite the right angle, H, divided by B. And now let's deal with the small triangle. We'll do the side opposite the right angle, which is B, divided by H2. And rearrange as we did before. We get B squared equals H times H2. Now we just add together A squared and B squared. We can isolate H from each term, and H1 plus H2 is equal to H. So we get H squared equals A squared plus B squared. This is Pythagorean theorem written in mathematical terms. Let's bring up the areas that we had before, and we'll see that they're the same thing, just written in different ways. H squared, or the area H, is equal to A squared, or the area A, plus B squared, or the area B. This is Pythagorean theorem.